In this lesson, we're going to cover IB Math AI/HL topic 2.3, also known as the topic of graphs of functions. So first, you have to understand the difference between sketch and draw. These are two commands given in your exams and also in your tests, most likely, where you have to really understand and distinguish the difference between the two to understand what to do. So sketching is far more easier. And when you're told to sketch, you just have to give an outline of your function. You don't have to really show out any coordinates, you just have to show how it looks. And it's usually recommended to also give you the x-intercept and the y-intercept. However, these we will talk more about later. However, when you're set to draw your function, it usually gives more points and it is way more difficult. So when you have to draw, you have to map out every point in your function. You have to clearly use not a pen, but a pencil and a ruler to get something like this. And you have to show out your function, you have to show out the x and y intercept, and you have to be very precise. That's the difference. So when sketch, you just give an overview on how the function looks like. When you're told to draw it, you actually have to understand, you have to show them the clear image of your graph. So let's talk about intercepts as well. So usually you have two intercepts, the x-intercept and also the y-intercept. So let me draw it like this. And to understand the intercepts, you actually have to put it into perspective. So the x-intercept is basically, you know that there is the x-axis. This is the x-axis. And x-intercept is the point where the x-axis is crossed. So you can have something like this. So if you have your function looking something like this, then you clearly know that here, right here, is your x-intercept because it crosses the x-axis. And you can clearly make a reasoning that the x-intercept is where x-axis is crossed. And the same thing, and you also have to know with the x-intercept, is that there can be multiple. Meaning that sometimes you may have graphs which go something like this, meaning that you have two x-intercepts. There can be 3, there can be 4, as many as you like. So y-intercept. It should make a lot of sense by now, but y-intercept is the same thing, however, with the y-axis. So here, in this case, in the blue one, it should be very understandable that your y-intercept is right here. Let's draw another graph. If I draw something like this, then you just have to understand where your y-axis is crossed. And that's exactly how to find it. So you can always put that y-intercept is where y-axis is crossed. However, these can be actually found very easily with graphing with your calculator. So how to graph with your GDC, you might be wondering. So first of all, you go to y equals. This is the button that brings out all sorts of different y1, y2 and y3. And you clearly have to know here that y is the same as fx. And for instance, let's take a graph. So you clearly know that usually in your exercises you're given something like fx is equal to 2x plus 3. And it's the same as y is equal to 2x plus 3. And for the sake of it, let's take this as our exercise. So if you want to find and use variables, like x in this case, then you clearly have to understand that x is located here. And you click on it, you get x. So our function is 2x plus 3. And then you graph it. And it now looks something like this. So, and usually in your questions as well, it's given that you have to find the intercepts, meaning that you have to find the x-intercept and also the y-intercept. So how to actually find these? So when you have your calculator, you have this button trace over here, and you go to second trace, and this gives you a whole lot of different commands that you can use. So if you want to find your x-intercept, you have to go to value and put when is x equal to 0. And you can understand that when x is equal to 0, y is 3. So this very clearly gives us our y-intercept. And if you have to make a very simple conclusion that x is 0, that because as you're looking for your y-intercept, you're looking where the y-axis is crossed. And you always have to know that y-axis is at x equals 0. And therefore, you can always find your y-intercept when you put value and you put 0, and that's how you find it. And if you want to find your x-intercept, this is how I do it. So usually I get a second graph, which is y is equal to 0. So as you can see here, now you have two graphs. And if you want to find there where x is crossing the x-axis, then you clearly can go to the intersect. Intersect means that you have two lines and when do they actually touch. And first of all, you start from your left, then you choose another one. There is usually no need to guess, and then you get that x is equal to 1.5. So I'm gonna write it down as well. Intercept and that's the most easiest way to get this as well. And in this topic, you also have to know how to understand different functions as well. So most of you already know how to do this, and it's quite more easy than you might actually think. So addition is very easy. You just add your two variables. If you have that y f of x is equal to 2x plus 1 plus g x, which is 3x plus 3, then you simply just add this all together, which is, you can write it as f plus g in your brackets, in brackets of x, is equal to 5x plus 4. And this, the first one, is also known as the sum function. So the difference function, I'm not even going to explain it, because it's the same thing. Instead of adding, you're just subtracting. However, quotient function is something much different. So this is when you have two functions. You have y, let's say is 2x plus 1, and y is 3x plus 5. Your quotient function is actually quite simple as well. It's just when you divide them, meaning that you get your function to be 2x plus 1 divided by 3x plus 5. And that's how you get your function. However, IB also wants you to know that you can clearly write this out in a much more different way as well. And you can always do it with your calculator as well. And you can do this by just adding your 2. So for the sake of this, I will delete this, and you know that the first y here is 2x plus 1, and the second one will be 3x plus 5. And if you want to get your quotient function, you can simply go to vars and go to yvars function y1 divided by, and then you go to vars again, and then you go to y2, and you will get the same thing as if you just put it in. It sometimes helps, however, I don't usually find the need to do it as well. And thank you.